Today we are going to start looking at stories about data that scientists collected about the animals on the fictional planet Romar. The scientists are trying to describe the life cycles of these animals, how big they are when they are born, how fast they grow at different ages, and how big they are when they stop growing. The scientists use centimeters to measure. Luckily, so far the animals on Romar have been very friendly and have let the scientists measure them. The scientists have collected data for the first 10 years of each animal's life, and they have found out that, unlike humans on Earth, every animal on Romar grows according to a particular rule. Today, we'll look at two of these animals and try to figure out the rule for how each of them grows. By the way, the scientists have sent us the data about the animals' heights, but they haven't yet sent any pictures of the animals. When you're graphing their heights, you may want to imagine what they look like. For some kinds of animals, the measures might be for height, as we would describe a bear or a monkey, but for some animals, the measures might be for length, as we would describe a tiger or a snake. All right, so the first animal we are going to be looking at is the copper. So this growth table is based on the data that the scientists collected that the copper is 5 centimeters tall at birth, and then it grows 4 centimeters each year. So let's start to look at the data that the scientists have come up with. So we have a table here, and in the first column we have the age of the animal, and then in the next column we have the height of the animal in centimeters, and you can see that based on what the title of the column says. So it says height in centimeters, and obviously the age, we are working in years here. So at age 0 or birth, the copper is 5 centimeters tall. So I'm going to write a 5 out here on the side, and you're going to see why I'm doing that in a second. So the copper at age 0 or at birth is 5 centimeters tall. And then at age 1, it grows to 9 centimeters because, remember, the rule is that it grows 4 centimeters every year. So the way we can check to make sure that our table is correct is that it was 5 centimeters at birth, and then when you add the 4 centimeters that it grew in its first year, you should get 9, which is its new height. So 5 centimeters plus 4 in its first year equals 9 centimeters. So that is correct. Let's look at how tall he is at age 2. So at age 2, now he's gone up to 13. So if we add 4 centimeters to its last height, which was 9 centimeters, 9 plus 4 is 13, so that is correct. So this chart so far is following the rule exactly. So now we have a blank. Okay, and I'm going to zoom in just a little bit. We have a blank here, so we need to figure out how tall this copper is going to be at age 3. So its last height was 13 centimeters, and we know that the rule is that every year that it's alive, it grows 4 centimeters. So 13 centimeters plus 4 centimeters would be 17 centimeters. All right, and we can continue this. At age 4, we're adding another 4 centimeters, and so his height will be 21 centimeters. And then at age 5, another 4 centimeters it will grow. So at age 5, it will be 25 centimeters tall. All right, so now what we're going to do is graph this data. Okay, so we are going to graph this data based on the table. We are going to put it on this chart and then create a line graph. So down here we have the origin. As we know, this is where we start. At age 0 or birth, our table tells us that it was 5 centimeters tall. So we need to go, the x-axis is going across. So I'm going to put x-axis here so we remember. This is the x and this is the y-axis. You always go to the x-axis first. So at 0 years old, it was 5 centimeters tall. So we are going to put our first dot of data on that spot. So that would be 0, 5. 0 going across, 5 going up. Okay, so that is our first data plot. Now we're going to go to age 1. And in our table, it tells us that at age 1, the copper was 9 centimeters tall. So we go over to age 1 and up to 9 centimeters tall, and 9 should be just below the 10, okay, on that line. At age 2, the copper was 13 centimeters tall, so we're going to go over to age 2 and up to 13. So 13 will be somewhere between 10 and 15. I would say that this could be 11, 12, and then 13 could be right here. So that shows 13. At age 3, the copper was 17. So over to age 3 and up to 17, which would be right about there. At age 4, it was 21 centimeters tall, so that's right above the 20. And then at age 5, it was 25 centimeters tall, which is right on the line for 25. So then you want to, whenever you are finished plotting your data points, you are going to take a ruler and draw a line connecting all of your data. Now in this case, we have a straight line. And why is that? Why would we end up with a straight line when plotting this data? Well, the reason why the graph shows a straight line is because if the growth that we're seeing is consistent every single year, it grows the same exact amount of centimeters, you're always going to see the same rate of growth. So it's going to end up in a straight line. So if the copper grows 4 centimeters every year, you're always going to see the same amount of distance between each data point and the same amount of growth. So it ends up being a straight line. So that is why you see a straight line whenever you have a constant rate of growth. All right, so the next animal we are going to look into is the flickerbill. Okay, so the flickerbill is 4 centimeters tall at birth, and it grows 3 centimeters each year. So we're going to finish this table together, and then you are going to create a graph for it on your own. So I want you to turn to page 295 in your SAB, and you will see this exact same chart or this exact same table in your SAB, and I want you to fill it in along with me in this video, okay? So we can see that the height was filled in for its first 2 years of life. So at birth, then its first 2 years. So at birth, it was 4 centimeters tall, and then the growth rate is 3 centimeters per year. So I'm putting my +3 on the outside. So 4 centimeters at birth plus 3 centimeters. So at age 1, he was 7 centimeters tall, and that makes sense. And then another 3 centimeters the year after that. So 7 plus 3 is 10. So we can see that these numbers so far are correct. So in order to figure out the rest of our chart, we're just going to add 3 centimeters each year. So 10 plus 3 is 13. So at age 3, it's 13 centimeters. Add another 3 centimeters at age 4, it will be 17 centimeters. I'm sorry, that should be 16. There we go, just needed a little white out. All right, so this is 16. Then we add another 3. At 5 years old, it is 19 centimeters. We add another 3. And then at 6 years old, 22 centimeters. And we're going to continue. Okay, so now we are down to age 10. The flickerbill is 34 centimeters high or tall. But now we see a jump to 15. So how can we figure out how tall the flickerbill will be at age 15 without going through and adding 3 and adding 3 and adding 3 and adding 3? Well, you can see that there's a rule here. So basically, each age is 3 centimeters plus that 4 centimeters that the flickerbill was at birth. Okay, so let's just look at age 5, for example. If we take 5 and we multiply it by 3, which is its rate of growth, that would be 15. And then if you take the 15, which is how much it's grown in 5 years, and add it to how tall it was at birth, That's 15 plus 4, and you get 19, which is correct. And we can just try at another random age as well. So at 8 years old, the flicker bill has grown. We're just talking about how much it has grown, not how tall it was at birth. 8 times 3, which is the growth rate, 8 times 3 is 24, and then if you add how tall it was at birth, 4 centimeters, you get 28. So we can follow this rule to figure out how tall the flicker bill will be at age 15. So if we take 15 and we multiply that by the rate of growth, which is 3 centimeters per year, 15 times 3 would be 45. But then we have to add how tall it was at birth, which is 4 centimeters. So at age 15, the flicker bill will be 49 centimeters. Okay, so let's try this with another example. Before we get to the 100, let's try this with another example. Let's just do 21. At age 21, how tall will the flicker bill be? And I'm going to show you exactly how we did that again. So you take its age and you multiply that by how tall it grows every year. So 21 years old times 3 centimeters grown every year. So that gives us a total of 63 centimeters. But then we can't forget to add how tall it was when it was born. So 63 centimeters plus 4 centimeters at birth, and we get a total of 67 centimeters. So at age 21, it will be 67 centimeters tall. So now it's easy to go right down to 100 and do the same thing. 100 years old times 3 centimeters, it grows every single year. So that's 300 centimeters. But then we add how many centimeters it was at birth, and we end up with a total height of 304 centimeters at age 100. Now what I want you to do is take this chart and turn to page 296 in your SAB and answer the 2 questions based on the flicker bill's growth. And then on page 297, you're going to take this table and all the information we just came up with, and you are going to graph the flicker bill's growth yourself. Okay? Good luck.